We've all been there, right? You're in the middle of doing something important, and bam, your favorite app or website just dies. It's frustrating. But what's really going on behind the scenes when the cloud fails? Well, today we're going to pull back that curtain and look at the incredible invisible architecture that's designed specifically to keep our digital world online. So here's what we're going to cover. First, we'll talk about why the cloud even fails in the first place. Then we're going to explore the huge global infrastructure built to stop that from happening, breaking it down piece by piece. We'll see how it all works during a real outage, and then wrap up with how you actually build an app that's, well, basically unbreakable. All right, first things first, let's start with a question that, honestly, we've all screamed at our phones at some point. So, why did my favorite app just go down? The answer isn't as simple as, oh, the server's down. Nope, it's way more interesting than that. See, the services we use every day live inside these massive physical data centers, and those data centers can fail. Things break. The real genius here is how the whole system is built, expecting things to fail right from the get-go. To really get this, we have to start big. I mean, really big. We're talking about the cloud's global footprint, which is organized into these massive things called regions. A region is pretty much what it sounds like. It's a specific geographical area on the map, like the Eastern United States or Western Europe. And the best way to visualize its scale is to think of it as an entire city. This is the 30,000-foot view of how the cloud is laid out across the planet. Okay, so if a region is our city, what's inside it? What are the neighborhoods? Well, that brings us to the next level down, availability zones. Now, this is absolutely the key concept to understand. Isolation. An availability zone, or AZ for short, is a cluster of data centers inside a region. But, and this is the important part, it's physically separate from the other AZs. It's got its own power, its own cooling, its own network. So, sticking with our analogy, if one neighborhood has a blackout, the other neighborhoods in the city stay lit. This separation, that's the secret sauce for what we call high availability. Let's zoom in one more level. We've gone from the city to the neighborhood. Now let's look at a single building on the block. And that brings us to the concept of a fault domain. A fault domain is basically the smallest piece of the puzzle that we expect to fail. Imagine a row of server racks in a data center, and they're all plugged into the same power unit and the same network switch. Well, that's a fault domain. If that one power unit fails, everything in that row goes down with it. It's exactly like your house. You put the kitchen on one circuit breaker and the living room on another for a reason, right? Same idea, just on a massive scale. Okay, this is super important, so let's pause here for a second. While all the big cloud players, AWS, Azure, Google, use these same ideas, they don't always use the same words. This chart is basically our Rosetta Stone. At the global scale, everyone calls it a region. Easy enough. When you get to the data center scale, AWS and Azure call it an availability zone, but Google just calls it a zone. Same concept, different name. And then down at the rack scale, you've got fault domains for AWS and Azure, while Google kind of handles that for you behind the scenes. Knowing these little differences is critical if you're working across platforms. So we've got our building blocks, right? Regions, zones, and fault domains. Now for the fun part. Let's see what actually happens when one of these pieces inevitably breaks. On the screen, you can see two very different ways to build an app. On the left, we've got a fragile design. The entire application, the whole shebang, is crammed into one single availability zone. It's simple, sure, but you're putting all your eggs in one basket. Now, on the right, that's the resilient design. See how the application is spread out, duplicated across multiple isolated zones? This is designed from the ground up with the assumption that something, somewhere, will go wrong. Okay, so let's watch this play out. Step 1, a failure event. Let's say a single server rack loses power in one of the zones. Now, for that poorly designed app, it's game over. Lights out. The entire thing goes offline. But look at the resilient design. This is where the magic happens. The system instantly detects the failure and boom, it reroutes all user traffic over to the healthy copy of the app that's running in the other zone. And the result? The application stays online and the users have no idea anything even happened. That is the whole point of resilience architecture. So, this is awesome, right? How do we actually apply these lessons? What are the fundamental rules for building an application that can actually withstand this kind of failure? It really just boils down to a few key principles. First, and this is the big one, always spread your application across multiple availability zones. That way you avoid having a single point of failure. Second, you've got to know the lingo. Understand the specific terms your cloud provider uses. And maybe the most important lesson here, resilience is never an accident. It's not the default setting. It has to be intentionally designed from the start. You have to plan for failure at every single level, from one tiny server rack all the way up to an entire region. And that really brings us to our final thought. The next time an app goes down, or maybe even better, the next time there's a huge cloud outage in the news, but your favorite app keeps working, you'll know why. It's because of this invisible architecture of regions, zones, and fault domains doing its job. It makes you wonder, doesn't it? Are the digital services you depend on every single day built on a solid foundation, or are they just one power outage away from disappearing?